Hello, welcome to the EZ-MES demo for equipment interfacing. EZ-MES is a real-time, browser-based manufacturing execution system for improving work and quality on the production floor. It allows the real-time tracking, controlling, and documenting of production processes. This video demonstrates the use of EZ-MES API to interface with SCADA systems and equipment using a middleware layer, in this case, Node-RED. This window illustrates a simple SCADA desktop. It contains two elements, namely an input to set an oven temperature and an output that shows the measured temperature. For example, the oven is set to 200 degrees. Once heated, the measured temperature will read 200 degrees. Suppose that the measured oven temperature needs to be recorded in EZ-MES. Production processes are described in EZ-MES with flows and steps. For this demo, a simple flow is used, which contains only two steps. The first step creates a traveler identifier and assigns a unique identifier to the part. The second and final step captures the actual oven temperature and stores it in EZ-MES. This flow is executed in EZ-MES by starting a new traveler. In the first step, identifiers are assigned to the traveler and the part. Once the traveler is moved to the next step, the current oven temperature is sampled by EZ-MES and stored in the part record. Notice the oven temperature is now shown in EZ-MES. If the oven temperature suddenly changes, then the value stored in EZ-MES will not change. The value registered in EZ-MES is a time-stamped record of the exact temperature at the specific moment that the production process entered step 2 of the flow. Should a rework take place, then the new measurement of the oven temperature needs to be stored in EZ-MES. For this particular demo, the traveler is moved to the first step. Then on to the second step, a new measured value is sampled and recorded in EZ-MES as seen here. The three main systems used in this demo are the EZ-MES software, a Node-RED middleware environment, and a ModBUS server. Node-RED is a comprehensive flow-based system for visually wiring together hardware devices. It was originally developed by IBM and is now an open-source JS Foundation project. In this demo, Node-RED is used to connect EZ-MES to a ModBUS server, which stores the actual oven temperature. ModBUS is a commonly used communication protocol to connect industrial devices, such as PLCs and equipment. Now it's time to take a closer look at the setup in EZ-MES. As explained before, the demo flow consists of two steps. In the first step, the traveler and part identifier are generated and set. The moment the second step is entered, an event is triggered. This event actually performs an action that tells EZ-MES to make an outbound API call. In this case, the call goes to a Node-RED environment. This call posts a JSON payload which contains the traveler identifier, its part identifier, and the number of the requested name value. In this case, this is the measured oven temperature. Now that the role of EZ-MES is explained, let's get familiar with the role of the Node-RED middleware in this process. The API call made by EZ-MES is received and handled by a separate flow in Node-RED. This flow will read the oven temperature on a ModBUS server and send this value to EZ-MES by way of an API call from Node-RED to EZ-MES. The complete setup in Node-RED contains three flows and also has a separate ModBUS server running. Instead of using ModBUS server, an MQTT broker or other common brokers for connecting industrial devices could also be used. The first flow is used to send the oven temperature set in the SCADA desktop to the ModBUS server. This is done so the temperature can be picked up by the oven. If the setting for the oven is changed by an operator, Its value is sent to ModBUS in accordance with a specific configuration of the flow. In this case, both the device number of the oven as well as the temperature value are sent to the address number 4 on the ModBUS server. The second flow polls the ModBUS server, which is in accordance with a specific configuration. In this case, the configuration would specify to read 2 numbers on address number 4. By doing so, the oven setting is read from the ModBUS server and then used to set the oven temperature. Next, in the same flow, the measured temperature is read from the oven and used to set the SCADA desktop. This temperature is also sent to the ModBUS server. As a result, the measured temperature is stored on address number 16. The third flow is used to handle the API call from EZ-MES. This API call includes a JSON payload. The name value number in this payload is used to obtain the correct oven temperature value from the ModBUS server. In this case, this is the value stored on address number 16 of the ModBUS server. Next, an API call is made from Node-RED to EZ-MES. This call sends a JSON payload to EZ-MES, which contains the traveler identifier, its part identifier, the name value number, and the measured oven temperature. EZ-MES uses this payload to accurately store the oven temperature in the part record. By doing so, EZ-MES can be used to fully track equipment measurements for all produced parts. Last, let's look at the actual calls being made. The debug window in Node-RED can be used to see the flow in action in real time. First, in EZ-MES, the API call to Node-RED is triggered by moving the traveler from the first step to the second step. The debug window shows that the API call is received together with its JSON payload. Next, in the Node-RED, the JSON payload is decoded and the name value number is used to read the correct oven temperature from the ModBUS server. And finally, an API call is made from Node-RED to EZ-MES to send the current oven temperature to EZ-MES. The response of this call shows that the call has been correctly processed by EZ-MES, as the error code value returned is 0. The traveler in EZ-MES now shows the measured oven temperature, as read on the ModBUS server. This demo illustrated middleware layers such as Node-RED can be used to set up a highly configurable interface to connect EZ-MES to industrial equipment and SCADA systems. Thank you for watching this EZ-MES demo for interfacing equipment. For more information about EZ-MES, please visit our website at ezworks.com.